Today I would like to show you how to categorize the effective nodulating plant with a non-effective nodulating plant. Like we said, when we have to first of all uproot the legume plant. Now for uprooting the legume plant, you must mark a periphery about at least 5 to 10 centimeters or a little more than that, depending on the growth of that plant, so that you are trying to take out maximum of the root portion. So it will be good, like we have shown in the digging part, we try to mark it, we try to remove using a khurpi as much soil as possible, and then we will use a spade to dig it deep and try to extract maximum of that. Now once you are uprooting it, it will come along with the soil. Try not to disturb the soil too much with your hands, because that may also break the roots, the lateral roots. It may also break off the nodules. So it will be better option to immediately wash the whole thing, so that the soil is removed from the rooting system. Do 2-3 washes, so that the root system looks very clean and the nodules are absorbed very cleanly also. So ensure that uprooting your legume plant does not break the rooting system and also does not dislodge the nodules. You should use both khurpi as well as a spade to dig it deep as much as possible and try to uproot the root system intact. You see in my hand, this is a chickpea plant which is almost 80 to 85 days old, which we have inoculated, and I have uprooted it from the field. So you can very clearly see that the nodules which have been formed is majorly concentrating on the taproot and the crown region. And the side roots which are already there, you don't find much of the nodulation in that. So basically this is also a very distinguishing feature of a inoculated plant versus a uninoculated plant. And there also the nodules will be formed, but they will be formed through the native rhizobia which is present there. So if there is a good nodulation and an effective nodulation, that means the nitrogen fixation which the mesorhizobium does inside the nodule will be able to contribute to the nitrogen nutrition of the plant. And this is what we would like to show you, and also later on I will show how to isolate the rhizobial partner from the nodules here. So this, like I said, is an inoculated plant. We have tried to see that the root portion is as much possible as intact we wanted to see, and we tried to uproot the plant with the roots very much intact. Even then you can see that there is a breakage of this taproot. So if it is, like I said, if it's an 80 or 85 days old plant, the rooting system must have gone much beyond the 15 centimeters, and for that to uproot a plant intact with all the roots intact will be a difficult process. However, now I would like to show you how do you categorize them. How do you say that if the field is having a legume, how do you categorize them as a good effective nodulation in the field? So we uproot at least about 40 plants or 30 plants, and then we take the number of the nodules in each of the plant, and then we categorize them as 50% nodulated or 60% nodulated or 70% nodulated. So now I will show you some of the variations which we found in the native chickpea fields that we have taken the plants from. So essentially when we take out the plant with the soil, you must see that when you are uprooting the plant, your soil should also come out as much intact as possible, and then you have to wash those plants and the rooting system in a bucket of water or under a very low flow of the water, and then after you wash it, you just place them here. So here I have 5 of these plants which are taken from the field directly. You can very clearly see, if I just take it out and show it to you, you can see still the nodules being formed there. The nodules are there, but the rooting system is very, very little, and this is about 45 to 50 days old plant. Even in a 45 to 50 days old plant, the root system is not so well developed, and probably we have lost some of the root system also while uprooting. But the nodulation, you can very clearly see about 4 nodules being formed here. So this is a low nodulating category where I can see about 4 to 5 nodules per plant. The root system is also less, and the number of nodules per plant is also less. So I have categorized them, 5 of these plants with about 4 to 5 nodules per plant. This is one category. Then from the same from another field, this is another field, the same field, and maybe a little. These are another set of plants which we have uprooted, washed the soil, and then again kept it, and then now we are going to take the number of nodules in this. You can also very clearly see the number of nodules here, single nodules and lobed nodules. Always remember, in chickpea, once the nodulation starts, initially it will be single lobed. After that it becomes multi-lobed structure. It is still a single nodule, but it's a multi-lobed nodule, unlike a soybean plant in which the root nodules are not lobed at all. So you will find these variations, lobed and unlobed nodules, in different legumes. Chickpea makes lobed nodules. So here there are, again, we have these number of nodules. So we count the number of nodules per plant and then see from one single field how many plants. If we have uprooted 15-20 plants, how much is the number of nodules per plant, and we average them out. And suppose if it is showing more than 50%, like if the average number of nodules for chickpea per plant is between 20 to 25 nodules per plant, we would say that it is an effective nodulation in the chickpea from the native fields. So I'll show you one more. So here you can very clearly see the nodulation looking much more than what you have seen earlier in the plants. The field is the same, the plant is almost 45-50 days old plant, and we have got few plants, about 10 of them here, with the nodulation a little more. Number of nodules per plant here is at least 10 or more. If I take the lobed ones, then it will be about 20 of them here. So these are another category. About 10 of these plants we have uprooted, where we find that the number of nodules per plant is much more than what I have just now shown. And even the rooting system, roots are also a little longer, and even though we are losing taproot here, but still the root system is much better than what plant I have just now shown. So essentially what we do is, we count the nodules per plant, and then we say that say about 30 plants we take from a field or 40 plants we take from a field, count the nodules per plant, and we average it out. If we get an average of almost 25 nodules per plant, we will say that the chickpea field is effectively nodulated. Now what do you understand by effectiveness? Effectiveness is the nodule should look pinkish in color, and when I squeeze the nodule or when I cut the nodule using a scalpel or something, it should look pink in color. That pink color is denoting the leg hemoglobin present inside the nodule. And that leg hemoglobin is an important part, because the rhizobium partner, which has the ability to convert nitrogen, atmospheric nitrogen, to ammonia, will function only if the partial pressures of oxygen are low there. And this leg hemoglobin, that pink color leg hemoglobin, is the one scavenges the oxygen and keeps the oxygen pressures low inside the nodule for the effective conversion of nitrogen to ammonia inside the nodule. So here you can very clearly see these are the lobed nodules of chickpea. These are the good ones, the ones which are showing pinkish color, you can very clearly see that. See this, and this brownish one are the one which is senesced nodule, which is already old. Now you will, if you squeeze it, you will not find the leg hemoglobin here. Something brown, some brown fluid will ooze out. So this is like a senesced nodule, and this will no more be an effective conversion of nitrogen to ammonia here. But in all these other nodules, you will find the nitrogen to ammonia conversion taking place. I'll either squeeze it, or we have a scalpel, so I can see this. Can you see this inside circular pinkish color? That is what is the leg hemoglobin there. And when every single nodule, if you cut and if you find this reddish central part, that means that nodule is active and is an effective nodule which converts nitrogen to ammonia. Now I will show, you can see here also, which I have cut here. See this pink central red color. Now I will show the one which is already senesced nodule, and you can see that so this is a senesced nodule. So if I just cut it here, you won't find. See the difference between this nodule with the cut portion and this nodule here. You can very clearly see this. So this is a senesced nodule which has almost now nil nitrogen fixing activity, and this is an effective nodule, active nodule with the nitrogen fixing activity. So if a plant has more number of this kind of pink nodules, that plant is able to convert nitrogen to ammonia. And basically we know that in India, for legumes there is hardly any nitrogen fertilizer application, because most of the farmers grow it as a marginal crop and they don't use any fertilizer at all. So whatever nutrient, especially the nitrogen nutrient which the legume needs, that it is able to do it on its own. It is converting the atmospheric nitrogen to ammonia, and that ammonia is now being converted into amino acids, and those are the building blocks for the protein. So whatever nitrogen nutrition is required by the legume plant, the rhizobial partner is able to provide that nitrogen nutrition to the plant. Farmers do not apply chemical fertilizer for legumes at all, especially in India. Another point I would like to emphasize here is we have been showing the the nodules on the plant. By and large, nodule number is a good indicator, of course, but like I said, if there are pink nodules, we know that it is going to be a good effective nodulation and nitrogen fixation plant. However, in chickpea, like I said, these are lobed structures. Every nodule, single attachment point, but this is a lobed structure. You have at least 5-6 lobes, or more than that, 10 lobes per nodule. It's a single nodule, but it's all lobed structure. For this simple reason, here in chickpea at least, we go more for the dry weight of the nodules as a good indicator of the plant which is able to be fixing nitrogen, not the number here, because number alone is not going to be a good parameter for categorizing the plant as an effective nitrogen fixer, fixed plant or not. So here we take the dry weight of the nodule. This parameter is also a constant factor. More or less for all legumes, we go for the dry weight of the nodule rather than the number of nodule. Initial screening, of course, we do go for nodule numbers in other legumes, not necessarily for in chickpea or in any other plant which makes a lobed nodule. There the dry weight of the nodule will be a better indicator compared to the nodule number. That is a So to summarize, I would like to say that when you are going, when you are working on the nodulated plant, any legume, which is having nodules, and specifically the pulses, the grain legumes, there we must remember, one, that when you go for uprooting the plants from the field, the soil should be moist. If it is not moist, it's difficult to dig and retain the root system of that plant. You will be breaking the roots, you will be breaking the nodules. So whatever parameter, number or weight that you will do will be underestimated. So ensure that your field is moist. At least 1 to 2 days before you must irrigate the field, and then you go and dig deep into the soil to take out maximum the root system without breaking it. That is point 1. The point 2 is, when you are seeing that the plant is wilted, or if the plant is stunted in growth, obviously you should avoid taking that out, because the root system will not be very good. So you must pick out a healthy plant to score for the nodules. Don't go for a plant which is stunted in the growth. Go for a healthy plant to take out, to dig it out, and then look at the nodule pinkishness, the nodule number, and ultimately the nodule dry weight. These two parameters, these 2 points we must remember while we go for nodule scoring. The third point is, when you are working with the isolations for rhizobia, when you go for this nodule, you want to remove that nodule, you must use a scalpel so that you take out some little part of the root also along with the nodule. Don't break off the nodule for any isolation, because you will be using some sterilant like a mercury chloride and ethanol for sterilizing the surface of the nodule, and if the nodule already has a pore in that, because you have broken it off, then it will get inside and your bacteroid will be affected. So you must remove the nodule with a small bit of the root portion for further processing of the nodules and trying to isolate the rhizobium in that. Thank you.